Sharpen skill for middle school students. Sharpen skill for middle school students is a series of simple school level questions which will help you to boost and improve your intuitive skill and also to drive away the math phobia in school students. In Sharpen skill for middle school students, in this session we have a right angle triangle, altitude A, base B and hypotenuse C, and a circle is inscribed in it. A circle is inscribed inside a right angle triangle, and you have to prove that diameter of the circle inscribed in a right angle triangle, the diameter of this circle is A plus B minus C. A plus B, altitude plus base minus C minus hypotenuse. The diameter of the circle, inscribed circle, the circle inscribed in a right angle triangle is altitude plus base minus hypotenuse. This is what we have to prove. Sharpen skill for middle school students. So the sides of the triangle are tangents to the circle. You can see A, B, C, we have marked the vertices, and the sides of the triangle AB, AC and BC are tangents to the circle. So let P, Q, R be the points of contact. P is the point of contact of this tangent, Q is the point of contact of this tangent, and R is the point of contact of this tangent. So P, Q, R are the points of contact of the tangents to the circle, and the sides of the triangle are tangents. So the points of contact P, Q, R. Now from center O is the center of the circle, we draw OP and OQ, the horizontal radius and the vertical radius. From center O, we draw OP and OQ, the two radii. Now radius is always perpendicular to the tangent, right? Radius is always perpendicular to the tangent, so these two are 90 degrees. Angle C is a right angle because this is a right angle triangle. The two radii are equal, and the two tangents from the point C, tangent CP and tangent CQ are equal. So this figure OPCQ is a square. From the point O, we are drawing two radii, one horizontal and one vertical. The angle between the two radii is 90. Each radius is perpendicular to the tangent, and angle C of the right angle triangle is a right angle 90 degree. So OP equal to OQ, that is the two radii, and from the point C, CP is equal to CQ, the two tangents are equal. So this figure OPCQ is a square. So if it is a square, each side must be equal. So each side is equal to radius R. Square means all the sides are equal. So each side is equal to radius R. So CP, right? CP will be equal to R. Similarly, CQ will be equal to R. Each side of the square will be equal to R. So CP will be R and CQ will be R. Now BP, from B to P, that is the total altitude BC minus PC. The total altitude BC is A, and this from P to C, it is radius R. So the remaining part B to P will be A minus R. Similarly, from C to A, the total base is B, and from C to Q, it is a radius R. So the remaining part from Q to A, it will be B minus R. The total altitude B to C is A units in length, from P to C it is the radius R, so the remaining part B to P will be A minus R. Similarly, from C to A, the total base, that is B, and you subtract this part R, so the remaining part QA will be B minus R. So this is A minus R and this is B minus R. Now BP equal to BR. You can see the blinking lines. BP is equal to BRY because they are tangents from an external point. From an external point B, BP is one tangent and BR is one tangent. They must be equal. So if BP is A minus R, then BR is A minus R. The two tangents must be equal. You can see the blinking tangents. The two tangents from the point B to the circle B to P and B to R, the two tangents must be equal. So this is A minus R. So B to R will also be A minus R. So BR is equal to A minus R. And now the same logic here. See the blinking lines? From the external point A, AQ is a tangent and AR is a tangent. From the point A, AQ is a tangent and AR is a tangent. So tangents from the same point A should be equal. So if AQ is B minus R, then AR is also equal to B minus R. AQ is equal to AR. Tangents from an external point. From the point A, AQ is a tangent, AR is a tangent. So AQ equal to AR. So AQ is B minus R. So AR is also equal to B minus R. So AQ equal to AR equal to B minus R. So we can see that the line AB, the first part B to R is A minus R, and from R to A it is B minus R. So the total length AB is equal to AR plus BR. Now this is C. Actually it was C, the hypotenuse was C. The altitude A, the base B, and the hypotenuse was C. So AB, that means C, is equal to this part A minus R plus this part B minus R. So C is equal to B minus R plus A minus R. The total length AB is equal to this part A minus R plus this part B minus R. So C, that is the hypotenuse AB, is equal to B minus R plus A minus R. That is C equal to A plus B minus 2R. B minus R plus A minus R. So A plus B minus R minus R minus 2R. So C equal to A plus B minus 2R, or 2R is equal to A plus B minus C. Now 2R is diameter, R is radius, 2R is diameter, right? R is radius, so twice the radius 2R will be diameter. So the diameter is equal to A plus B minus C. That means diameter is equal to sum of legs minus hypotenuse. The diameter of a circle inscribed in a right angle triangle is equal to sum of legs minus hypotenuse. So this is what we were asked to prove, that the diameter of the circle is equal to A plus B minus C, that is altitude plus base minus hypotenuse. And this is what we have got, diameter equal to altitude plus base minus hypotenuse. So that was Sharpen skill for middle school students. We will be coming back with many such videos, and you can also write to us to join our live sessions at any time. You can join online, and all our services are entirely free of cost. So anyone, any student all over the world can join our live sessions. So we will come back with more interesting mathematics. Till then, thank you and goodbye.